Okay, hi everybody. Today I'll be doing a malware analysis for my school project, and the analysis I'll be doing is basic static analysis. And as you can see on my screen, this is the targeted malware that I'll be analyzing today. So first, let's look at the VirusTotal website they've used to scan the malware. So as you can see, I already uploaded using a zip file containing the malware, and two of the antivirus returned with the result of being malicious and being a Trojan under the malware family Windigo. So let's look under the details and check this if there's any information. As you can see, the file size is 4 MB, and under warning, you can see that it contains more than one Windows executable. So that's the only information I got out of here. Looking at the relations, we can see that there's a domain being contacted by the file, but it's not detected to be a malicious or suspicious domain, so we'll be skipping that. And you can look under the job file. This file is the one that I showed you previously on my VM. So out of 75, there's 65 antivirus that thinks that is suspicious and could be a malicious file. And under here, we can see that there's another injector.exe file, which is also suspected to be a malicious file by 60 antivirus. So we'll be moving on using the graph summary to analyze further. So as you can see, this is the zip file being submitted by me, and here is a contacted domain. So but there is so there's no antivirus that think that this is suspicious, so I'm gonna skip analyzing that for now and look at the main file, which is the one that I showed you previously on my VM. So from here we can see that it's a executable file, Windows 32-bit, and under the detection we can see that it could be a Trojan with or spyware, right? As you can see, there's many antivirus that suspect that this is a Trojan. Sorry, a Trojan over here. A lot of them suspect that it's a Trojan, so most likely I can say that this is a Trojan type of malware that we are analyzing. And over here we have the injector.exe, right? So it's also a 32-bit Windows executable, and looking at detection, it is telling us that this could be an injector tool, hacking tool used by the Trojan, right, to aid the Trojan file to inject into the targeted client machine. Yep, so from this VirusTotal tool that I'm using now, I can conclude that we are doing a analysis on a Trojan type malware, and there's another extra injecting tool that we have to be beware of that's using to aid the Trojan file. So next we'll be moving on to our VM. So first we will be using the PID. So what this do is I'm trying to check if the file is packed or not. So okay, in our initial scan we can see that nothing was found. So most probably the file isn't packed. But let's try out the deep scan. We can see that it changed into a window icon graphical format. So what does this mean is this window icon graphic format actually is used by Windows to give a icon to application like these files over here. So from here, I don't see what is the packer. So let's move on to pressing the extra information over here and trying to understand more. Okay, under entropy, you can see that it's rated 7.99 out of 8, and at the side, the brackets, they say it's packed. So what entropy actually mean is the level of obfuscation of the data in the malware file. So 7.99 is a very high rating, which most probably stands that saying that the file would be highly or more likely to be packed, right? So because when it's packed, the data are more obfuscated. So let's look at the EP check. It says it's not packed, so I can assume that the data in the entry point location of the malware file is not packed. And under fast check, the result is packed. So I can throughout this whole like tool that I'm using to analyze, I can most probably conclude that the file is most likely packed, right? So this children is most likely a packed malware, but it's fine. We'll be moving on. So we're moving on to looking at the mal the file type. Okay, so over here you can see that obviously it's a .exe, so it's a Windows executable. But how many bit are there? So let's check it out using the WinHex tool. Right, over here you can see the PE space L, right? So based on my research, the L here actually stands for is this file will be a 32-bit file, and if the letter is a D, it will stand for the file is a 64-bit. So it's also corresponding to the virus total. As you can see, it's a Win32 executable, so it matches the virus total uh, too. And now let's use the WinMD5 to make sure that the file is the same as what we downloaded. Right, so let's open the file. Right, as you can see, the hash here is 94A1. And on our side, we can check on our source of the virus where I downloaded it on virusshare.com. You can see that the MD5 hash is 94A1, which is the same, which proves that the malware is not audited by anyone when downloading, and the virus uploaded to the virus total is valid. So under status, you can see that it's unknown, which means this hash is not matched or not found in the database of WinMD5, which these two can't tell us that if it's a known malicious file, right? So through these two, I can only conclude that the file that I have downloaded is same as the original file that I intend to download. Okay, so next we can try to identify the compile date. So now you can use the tool called PE view, right? And let's open this up. So most probably it's gonna be under here, somewhere here. So let's try to find it. Da- da- Okay, sorry. So it's under the image file header. So as you can see, the time date stamp is on 2020 October 24. It's a Monday, and this is the time that the file is being compiled. Okay, and this just give us a base like information on when when this whole Trojan file is compiled, right? So let's move on to finding the imported DLL libraries. Right, for this I'll be using dependence worker. So let's open the file. Okay, as you can see, there's a total of 1, 2, 3, 4, 5, 6, 6 DLL being imported. But inside all these DLL, there's even more DLLs being called and imported. But mainly there's only 6 DLL being imported. So after finding these, we will move back to looking at the P view, right? Based on my research, there is a subsystem that is needed for this malware. So let me find it. Yep, here. So as you can see, under here there's a subsystem category, right? And it says it needs the image subsystem Windows GUI, right? So from here we can see that the data is 2, which shows that this like applications or this children file is most probably to to be run in the GUI environment instead of the CUI environment, which is the command line. So this value just shows us that the file should be run in the GUI environment. That's all. Moving on, we will be looking at the imported APIs that is suspicious. So let's look over to the imported address table. So here are all the APIs being called, right, when the malware is run. So some of the malicious APIs are, so first one we have this set computer name. So this is a Windows API that is used for the malware, that could be used for the malware to retrieve the name of the local machine for enumeration, right? And moving down, we can see, let me find some suspicious APIs. Yeah. Okay, as you can see at the bottom, three APIs called. You can see that there's a WinHTTP open, WinHTTP read data, and WinHTTP DLL being called, right? So what does the WinHTTP open does? It actually basically this API is provided by this DLL over here. And what does it do is it allows the connection from an application, which is the Trojan file, to open a connection with a domain, right? Or to make a HTTP request. And the read data API, what does it do is it actually able to read the data from like a web page to HTTP session from the domain. So these three APIs actually corresponds to the analysis over here. As you can see, there's the domain contactor, as I previously said. So most probably those three APIs are used to contact the domain over here, right? So these three are network-based indicator. Alright, let's move on to finding some host base, right? Previously I've said the set name, right? And there's also a As you can see under here, some host base would be a global add atom, right? These API functions, right, allow malware to communicate to other process to store like small data and retrieve later, and possibly used to pass data between application, right? And under at the bottom we can see that there's a create file, which is also a host-based indicator. It could be creating like a malicious file, and and if it's combined with a API called get Windows directory W, which is over here. Sorry, yeah. So what does this do is this malware file could be getting a directory that they want, right? And then creating a file inside it. And then at the bottom, you can see that there is a write file over here, right? So they could be finding a directory that they want to insert the file or inject the Trojan file. Then it will create a file over here, and then maybe write the malicious code. Sorry, write the malicious code into the file or something like that. So these are some of the host-based indicator we have, right? And the rest of my host-based indicator will be in my report, so head over there to check it out because I can't really find them now, so I'm not gonna waste more time over here. Okay, so next I'll be using is the next tool I'll be using will be bean tags. So what these two actually help me analyze is the strings that are in the Trojan malware. So let's open this up. Okay, so as you can see, these are all the strings that is found. So what are suspicious strings that I found is over here. There's one that says the application has made an attempt to load the C runtime library incorrectly, which is like an error message that indicate that the DLL there may be a presence of like DLL injecting, right? Or the file could be corrupted. So moving on, there's another one saying that indicates this indicates a bug in your application, right? And it's most likely a result of calling a MSIL compiled function from the native constructor from the the DLL main. So the DLL main, right, actually points the issue to in mixed code examples. So what is a DLL main used to do is it manage the managed and unmanaged code, which may allow incorrect interacting. So this can be exploited by the malware to inject a managed code into the native application, right? As you can see over here, they say indicate a bug in the application. So most probably the Trojan are injecting something into the application, resulting in it saying there's a bug in your application. At the bottom, you can see that it again says that this indicate a bug in your application. So these few strings are kind of suspicious, right? Moving on, you can see that the application under the string say that this application has requested the runtime to terminate it in an unusual way. So this is suspicious because this is like a error message that says that the application is terminating itself in a very unusual way, right? This may show that the application is encountering severe errors or like severe bugs, right? And has instructed itself to terminate themselves forcefully. So, yep, so this string I find is kind of suspicious. And based on my research, malware may actually do this to invade the detection or disrupt the detection analysis, right? This is so that the targeted system, does not um, it, to make it harder to be detected by the client machines. So let's move on and find. There's also an so let's move on. There's a glits.exe file that I found in the string over here, which is also kind of suspicious. It is a exe file for this application over here, right? So what I'm thinking is maybe this application being downloaded is one of the method that the Trojan is using to inject itself. So when going through the above strings, they saying that there's a bug in your application and is requesting to terminate in runtime in an unusual way. So I'm assuming that maybe this tool over here is being used for injecting the Trojan. And due to the injection, this tool that they downloaded, right, is having a bug. Right? So by doing so, maybe they are covering their tracks, saying that there's a bug in the application and um, you can't open it or something like that to make it look like it's just a normal error happening for like the target users to not identify it. And at the bottom, you can see that. Sorry, let me find. It is somewhere here. Give me a second. Yeah, okay, over here you can see that there is a directory pathway to this directory which could be used for the injection of the Trojan. Maybe they are putting in some malicious code in this directory. So yeah, that's all the suspicious. So basically, in my conclusion, I can say that after doing this whole static analysis summary, the file, sorry, the possible characteristic and behavior of this Trojan type malware is most probably has something to do with file dropping, registry modification, certificate stealing, and process injection. Right. So thank you for all of you looking at this for looking at this video. I hope this video is helpful.